Hi guys, hope you're all doing well. It's been a while. Um, I got some time over the next couple of weeks to make some tutorials, so I'm gonna try and make a few of these. I had gotten a few questions about this animation over the years since I put it up a while ago, and I had gotten another question recently about somebody who was having trouble getting these edges to render properly, and I never uh, I never tried to render this, so I didn't know there was an issue with the edges rendering. But it turns out there was. But I did figure out a way to make them render properly, and I think it just has to do with Lightwave's edges rendering is still a little bit quirky. Um, but I did find a way to make it work, and it works well. So I'm gonna start with this one, and the other reason I think this one's kind of cool is because it shows how you can convert code into nodes. So it's basically we're going to convert this code here into nodes in Lightwave, and I'm going to do a few additions for the animating, but that's pretty much it. I figured this one's pretty easy, so it's a good one to start on. But let's just get started. Okay, so the first thing we need is an array of points, and the way I'm going to do this, I'm just going to clone a point on the z-axis, and I'm doing meter apart, and we'll do 1,000 points. So that's going to be the max number of points we'll have in our on our sphere. I'm just going to name it fib points. So we'll save that. So that's all we really need for this part. So I'm just going to go to layout. I'm going to load those points. So those points just gives us an indexable array basically. So I'm just fixing the grid size, getting everything out of the way, putting it on wireframe or vertices so we could see them. So now all we got to do is get these to go on a sphere. And the way we're going to do that now, I'm going to do it in the displacement texture here. I'm going to use node texture, but you could do this in node deformations. The reason I'm doing it this way is because I may go a bit further with it where I want to do more deformations after the fact. So I'm just going to do it in here with node texture. So the first thing we're going to get is a spot info. And then we're going to get a vector subtract, or we get a split vector because we got to get the z coordinate. And the other thing we have to do is we have to take into account that all our points aren't at the origin. So we're going to get a vector subtract, and we're going to get a make vector. And then we're just going to subtract our point position from, well, right now it's going to be 0, 0, 0. So you'll see that they'll all jump back to the origin. So then everything we do will be in between. We'll pump into that make vector node. So the first thing we're going to do is we're going to floor that z. And if we look at this code here, you can see the first thing we have our 1,000 samples, and we have our indexable array. So the next thing we need is this variable called phi, which is basically just what we need is the golden ratio in radians. So the way we can do that is we're going to get AS tools math pi, and we're going to get a multiply node, and we're going to get a subtract, or we get AS tools square root, and we also need a subtract. So the way we can get the phi in radians is we could get 3 minus the square root of 5 multiplied by pi. So that's what I'm doing here. I'm just taking the square root of phi, subtracting it from 3, and then I'm just going to multiply that by pi. And that'll give me phi in radians basically. So that's all we need for that. So the next thing we need to worry about here is the loop basically, which is where we'll use our index, our indexed points. So the first thing we're going to deal with is the y coordinate. So the way we get the y is we need to get, I'm gonna, let's see, what do I get first? Divide, and we're gonna divide by 999. That's, I'm gonna animate that eventually, but for now that's the samples minus 1. You'll see that in the code if you look at it. And we're going to multiply that by the index. So you can see right there we got I divided by samples minus 1. And that's what that's giving us right there. I divided by samples minus 1. And the next thing we need to do is we need to do 1 minus. See, this 1 minus is the last order of operations, so keep that in mind. So what we need to do first is multiply that by 2. And then we could get a math scalar subtract, and we could do 1 minus that. So we'll do 1 and then we'll subtract that from 1. And that will give us the y coordinates. So you'll see if we go into the y, it'll just push all our points where they're supposed to be on the y. But we still need to deal with the x and the z. And the way we deal with that is with sine and cosine. So, well, before we get to that, we need this thing called radius. It's another variable here, and that's square root of 1 minus y times y. So we'll copy this square root, and we're going to need to multiply, and we're going to do y times y. And then we'll do 1 minus that, and then we'll go into our square root. So that gives us the variable called radius. And then the next part we have to deal with is this theta, which is just phi times the index. So we'll just take that variable we created, phi, which is in radians. We'll multiply that by the index, which is this floor right here. And that's that. So then the next thing we need the cosine and sine of theta multiplied by the radius. So we're just going to get trigonometry, cosine, trigonometry, sine, and all we're going to do is we're going to cosine and sine of theta, which was what we just created in that last step, which was I times phi. And then all we're going to do is multiply that by the radius for each one, which was this variable here that we created. And that's pretty much it. So then the cosine goes into the x, and the sine goes into the z. And you'll see that that'll give us the Fibonacci distribution over the sphere. So now I am going to do a little bit just to animate this. First I'll tidy up these nodes a little bit. So it's not really too much more to animate it. There's a bunch of different ways you can animate it, but for what I did here, it's pretty simple. So the first thing we want to do is we want to animate them coming out from 0. So the way we can do that is we can just animate that divide. So instead of doing 1 minus, or the index minus, or the index divided by 1 minus the sample count, which is 199, we can just animate that from 0 to 199, in that divide there. So we'll just animate that from 0, which actually you would want to do And I'm doing it over 300 frames, so it'll be 10 seconds. So it's going from 0 to 999 over 10 seconds. But you would actually not want to go to 0. It really won't make too much of a difference here, but later on you want to go from like 0.0001 to 99, just because you shouldn't really divide by 0. But it really doesn't make a difference here, but it will when I do the lines. And what else I'm doing here is I'm just multiplying that y divided by times -1 because it's not coming out from the right direction. So now it's coming out the way I want it, from the top to the bottom. So all I did was I just took y and then multiplied it by -1. So that gives us that part of the animation. Now I also want them to disappear too from the top to the bottom. So they're going to come out and then they're going to disappear once they come fully out. So the way I'm going to do that, I'm just going to add to the, should be from that floor that I'm adding from. I don't know if I fixed that or not. I don't think it'll matter too much. So on frame 500, I'm going to go from 999, or from zero I'm subtracting here. So I'm going from -999, from 0 to -999, basically, coming out of that Z. And you'll see what that happens when I plug that in. And that's going from 500 to 800. So for 200 frames, it just stays there. So that's pretty much it. The next part we're going to deal with is getting the lines in the either instances or hypervoxels. I haven't decided yet. Okay, so to create the lines, what we're going to do is I'm just going to select those first 2 points, put them in a new layer, create a 2-point poly, give it a surface of lines, and we'll instance that. And for the caps, I'm just going to create a ball and then cut it in half. I didn't want to get too elaborate with this. You could do a lot more, but I just wanted to do it real quick just so you could get the idea of how to do it. So I'm just going to cut the back side of this, stretch it back to the origin a bit. Put a back on it. And then I'll just merge them points. I'm just fiddling around with it because it didn't merge all the points. I should have just scaled it to 0, which I didn't do. So I'm just merging them all. Now they're not in the center, so I got to fix them. I could have just hit F2 here, but I didn't realize it was right on the origin. Okay, so that's all we needed to do. Now I'm just going to do a little bit of a rounder on that one edge. Just so it's not sharp there. Then we'll give it a surface name. I'll call it caps. Set the smoothing. You guys can make the caps whatever you want them. I mean, you could get more elaborate with different types of shapes. So I'm just making sure I don't have any non-planars. I notice I have a 1 point poly. I delete that. Then I'll just save it and go over to layout. And we'll deal with the lines first. Now, I thought this would have been easier to get these lines to render, but Lightwave and the edges is still kind of quirky in some cases, and this is one of those cases. So right now I'm just turning the edges on. I loaded that line that we're going to clone, and I turned the edges to 0.025 meters. You can see it there. So now what I'm going to do is I'm just going to add the instances on that edge. So I'm just going to turn off so it doesn't render, so the base doesn't render, and then I'm going to add DP instancer to it. I'm going to add that object. I'm self-selecting here. Going to put on grouped, put on pivot, and I know I'm going to need a total of 199 or 999 lines. So I just put the max to 999. And I'll go into the nodal. So first thing we need is the index, the instance index. So I'll get instance info. And then I'm also going to need the point index of the point layer. So I'm going to get point info. And I'm going to set it to the first layer. Points. Copy that. Because we need to get distance between the previous point and the next point. So now I'm just subtracting those two, the world position of each, and I'm going to create a vector or get a vector length, because that'll tell me how far the distance between the 2 points are. So now I'm going to get a math scalar add. And for now, I'm just going to add one. This is going to have to change. And this is where the lines rendering these edges gets a little quirky. And it's also where a person is having trouble to getting this to work. I didn't even realize this was an issue because I never tried to render it when I did the original demo. So all I did was I put the world position into the position. And now what I'm doing here is I'm just using the length as the scale on the Z. And for the X and the Y, I'm just keeping it at 1. So now all I'm doing here is I'm getting a line 2. I'm just going to line from the first point to the second point. And you'll see that'll, and if I go into the rotation with that, you'll see that'll give us the lattice there. And you'll see this will work fine when you're previewing OpenGL, but it won't render properly. And I'm not 100% sure why that is. Now you'll see I go back into that points layer and I fix that divide because I don't want to be divided by 0. So this is the points layer, and I'm just going to put it at 0.001 just so it's giving me a number. But that still doesn't cause it to render properly. It's really weird. I'm not 100% sure what's going on with edges, but in order to get this to render like I wanted it to, what we got to do here is, see, I think I demo what happens here if I don't do this. Or maybe I don't. But what we're going to do is we need to start, when we start this out, we want it to be at -1. So we're going to subtract a point. And then at 500, when we start the second part of the animation, we want it to step to +1. So basically that second point needs to go from -1 for the first part of the animation and then step to +1 for at frame 500, the same frame that we started that second part of the animation. And I'm not 100% sure why that's doing that. It's something weird with the way that Lightwave's rendering the edges. But if you do that, it'll allow you to, you'll see that it'll render it how you expect it to. And I didn't run into this when I originally did this setup because I never rendered it out. So I didn't realize that this was an issue with rendering these edges like this. I thought that I just didn't do it, so I didn't know it was going to be an issue. But somebody else ran into the issue, and this is how you got to fix it. So that works fine once you do that, and it'll render perfectly fine. So all I'm doing now is I'm loading that cap, and we're just going to do the same thing. I'm going to put the instances on that cap. I'm going to go into the scene editor, turn that cap off so it doesn't render. Add DP instancer. I'm going to add that cap to itself. Layer 3, add selected object, grouped, put it on pivot, and I'm going to need 1,000 of these because we have 1,000 points. Go into the nodes, and it's pretty much the same thing. I'm going to get point info, or we'll get the instance info first, then I'll get the point info. And just going to set it to the points layer. And there's a lot of stuff you can do with surfacing with this as well, but I'm not going to get into that. I'm already going on 25 minutes. So I just put the position of the points onto the position of the instances. And right now I'm getting an align too, so we'll align from that position to 0, 0, 0, which is just the center of the origin. And that'll, and if I go into the rotation, you'll see. Now that gives us a pretty cool effect actually too. It's kind of like one of those, I forget the name of it. But I want to flip them around the other way, so I'm just going to turn the, so now all I'm doing is I'm going to scale down the caps so that they don't cover the whole thing. So that's pretty much it. That's all there is to it. Now you can set up the render however you want. I mean, I didn't have any issues rendering this at that point. Now, I did use motion blur passes because of using instances like this. I find I could get better motion blur using motion blur passes. But I don't think you could probably get away with not doing it that way. You can see in the scene that I put in the description what my settings were. So that's basically it. Hope you guys got something out of it, and that's how you can deal with that error with the edges. I didn't know that that was an issue until somebody had brought it up to me, but that's how you can deal with it. Alrighty, hope you enjoyed it. Take care.